Good morning, everybody. Welcome to our talk on attacking next-gen roaming technologies. The pieces you see on the slide are not exactly next-gen, but I encourage you to find out what these pieces are. In any case, my name is Enno. This is Daniel. Hello. We are both security researchers for a German security assessment and research company called ERNW. I'm acting as a replacement speaker for Hendrik, who's the telco team lead at ERNW. He had a nasty car accident on Monday. He's mostly better than Bruce, so nothing really serious happened, but it was a kind of, they helped his girlfriend and him at another accident at the side of the road, and another car crashed into the group. So it was quite nasty, and it's the reason why he can't be here today. I have a background also, like Hendrik, in large-scale network environments and telco security, so I hope I will be able to fulfill or to fill the Hendrik's role here. Daniel and I have given a number of talks at Black Hat in the last 10 years on stuff like MPLS security, Cisco VoIP security, stuff like this. So this gives you an indication of the type of stuff we usually do. And today we are going to cover briefly SS7 and diameter. Actually, the agenda of the talk is quite simple. We want to give a brief technology overview, namely of this thing called diameter and the role it has in telco networks, namely in the context of roaming, when people who have a subscription in one provider's network are physically located in another provider's network and establish calls or establish data connections as well. Then we'll discuss what types of attacks exist in these environments, especially related to the protocols we cover. There will be a tool release. It's Black Hat time, so there will be a new tool that Daniel wrote, and he's going to show. And obviously, we'll try to derive some conclusions what this means as for security in telco networks in general, and in particular when it comes to diameter. Let's start with a quick view what has been available in telco networks for the signaling between providers so far. That is, there is one main, say, protocol or protocol suite called SS7, Signaling 7, System 7. That one is used for, say, signaling between providers when it comes to authentication of subscribers in roaming scenarios, when it comes to exchange of information about these subscribers. And the most simple situation when you're a telco subscriber is, say, we have Alice and Bob. Alice is subscriber in provider A's network, and Bob is in provider B's network. This is not what we are going to cover in detail. The thing we are going to look at is the roaming situation when Alice actually is in another provider's network. And then what happens is a specific type of interaction between the provider where Alice is physically located and attaches to the network, and her, as it's called, home provider, which holds the authentication information when it comes to Alice, which holds all the information as for the contract and the subscription and as for the charging. And this type of interaction and the until 4G, this type of interaction, which is about retrieve authentication information, get the encryption material, get all types of information about the subscription, and updating the location of the subscriber. Like, okay, now Alice is located in some remote country in another provider's network. All these interactions in the past have happened through SS7. SS7, there has been quite some security research on it. A number of talks were given, namely at the CCC event. There were some papers, some blog posts from some guys, so we can consider it to some degree well researched. And there is even, funnily enough, from Sense, which from my perspective don't exactly have a reputation of being experts in telco security, but there is a very good paper from one guy in the SANS context, which did a kind of vulnerability classification. And the classification of the types of exchanges used within SS7, like, okay, there are some exchanges, some messages which are only meant to be transported between providers. There are some which are meant to be used within one provider, but do not necessarily have to be exposed to the outside world in a roaming exchange to other providers. So there is this classification, and in that paper there is a classification of, say, these categories and types of exchanges within SS7, and the attacks related, which can occur in the context of specific messages. I'm mostly telling this to make you aware there has been some research, and there is already some understanding what types of issues can arise from SS7 and how these can be mapped to exchanges and what actually happens between different providers. There is a tool.
Yeah, as for SS7, I did implement most of the attacks last year and released the tool to test your network for those well-known attacks on SS7 networks. And it's already released. I wrote a nice article on Insinuator about the tool. It's very useful to check if you as a telco yourself are vulnerable to those attacks. But anyways, you will need a legitimate SS7 uplink to use that tool properly.
Which actually is a quite heavy restriction when it comes to doing security research, needing this type of uplink, as you can't do this, even if you have the tool and you get the tool running, or other tools, but I would say this is the most important one. You can't do this from home. You need this, say, type of access to that mostly close, or as it's called in telco space, walled garden, where the telcos interact. We will see this might be slightly different with Diameter. As for the tool itself,
yeah, this is what the tool looks like. So, as said before, it implements various well-known attacks and just tests for those attacks with the send routing information for short messages, or if you could resolve an MS ISDN into an IMSI via the send IMSI message, and so forth and so on. So this is what a typical test output would look like. But we're not here to talk about SS7.
We are here to talk about the newer stuff, which is used in 4G networks. Say important properties of 4G networks here is everything is based on IP. There is not this strict separation between an IP-based, say, data transport and a circuit switched voice thing as we had in 2G and 3G. In 4G, it's all IP. It's somewhat logically separated. There is still a data channel and a voice channel implemented by so-called bearers on the smartphones or on the phone side. The phone, and in some of the slides, will be called the UE, the user entity or the user equipment. And the role that so far SS7 had for the signaling between providers, namely in the roaming context, this is nowadays done by Diameter. Diameter there's different entities and parties involved in the specification of Diameter. There is a thing called the base protocol, which Daniel is going to be discussed in a second. That one is specified from the IETF space in an RFC. But given that Diameter originally comes from the telco world, the 3GPP, which is the main specification body for telco technologies, has a number of their own specifications which mainly describe so-called applications. Initially, Diameter, as the name might indicate, was meant as a successor of radios. So mostly used for AAA, authentication authorization purposes and accounting. And there is this wordplay. They try to come up with something which gives the abbreviation Diameter. as opposed to radios. But nowadays, diameter is used as a multi-purpose signaling protocol for all types of interactions between providers. And the thing is, it's not just like a protocol for the exchange and for certain messages. Again, those will be discussed in a second. But it has a kind of own routing logic. So entities participating or speaking diameter have, an own layer of how to forward messages to other nodes and how to find each other and how to talk to each other. This will become important at some later point. And another thing that to keep in mind is that diameter can be, transported above or over TCP. But most cases that we know, I don't think we have ever seen diameter over TCP.
No, not in production anyway.
In telco world, it's very common to use SCTP, the stream transmission control protocol, as the layer 4 protocol. So usually you see a diameter being spoken and implemented over SCTP. And now looking at the roaming scenario in the 4G, in the so-called NextGen world, there is several things to keep in mind. As I mentioned, there is a separation between data and voice, and there is the signaling, the out-of-band thing for setting up the call and for getting subscriber information. All these channels, while logically separate, from the transport level, implemented across points where the providers meet. Those points in the old world, those were called the GR access, and now they are called the IP access, and most large telcos offer this type of service. You can, just an exchange network for specific things between providers. When it comes to voice transport in 4G networks, that is usually done by means of voice over LTE, VoLTE. And technically speaking, there is, next to the data channel, which exists anyway, and which is IP-based, there is a second channel, a second bearer for the voice transport, which is realized over IP. And the main component involved in the telco infrastructure is the so-called IMS, the IP multimedia subsystem. And when you look at this, there is three main things from the telco world has all types of components with specific names, with specific abbreviations. There's three that are of importance for what we are going to discuss. There is one entity called the HSS, the Home Subscriber Server. This is the central database for authentication and for all types of data related to an individual subscriber. Then there is the MME, which is the Mobility Management Entity. That is the kind of, component doing all the control plane for actual user subscriber connections. So that component that terminates or has the data, okay, in this cell there is that subscriber attached to the network and handling the connection and the call data, including handling the keys which are used for the over-the-air encryption. And then there is the IMS, the IP multimedia subsystem, which kind of terminates and handles the voice over LTE, so the user plane. The MME is the so-called control plane, and the IMS implements the user plane. And there is two scenarios which are relevant for our discussion. Imagine Alice is roaming, and Alice is in provider C's network. And now Alice establishes a voice over LTE call, which is protocol-wise handled by RTP and ZIP. The thing is, this connection actually can be encrypted between Alice and the IMS. And one case is the IMS sits in Alice's home network. Then this is called the home-routed IMS. And the other case is that the foreign provider, where actually Alice is physically located, has an own IMS terminating the SIP connections with Alice, and then somewhat hands it over, depending on where Alice actually wants to talk to the home IMS via a so-called NNI, network-to-network interface. This scenario means that in case the connection is encrypted, which obviously from a security and privacy perspective makes sense, but which isn't, I wouldn't say it's that all providers actually encrypt their voice over LTE connections. We did some security testing in one provider's network some time ago, and it was not, the whole thing was unencrypted, and they told us, well, for the purpose of your testing, we disabled it. But trust us, usually it's enabled. But it just has been turned off for the testing. Derive your conclusions. In any case, in this scenario, the foreign provider entity might be involved in the encrypted channel of Alice, which, say, depending on lawful interception requests or stuff, might be in the very interest of the foreign provider. But from those two, say, architectures, this one is much more prevalent. All this is still a bit, TE is still a bit in the beginning in mobile networks. So this is more prevalent, but from, say, certain entities' perspective, this might be much more interesting for, say, lawful interception and stuff. So we will see this at some point, probably. This is what we expect. In between those components in the telco world, which all have their specific names, there is types of interactions, and these interactions are bound to so-called interfaces. Those interfaces don't have to be, but in some cases are, actually separate physical interfaces. It's more or less about logical structuring. Once this component talks to this one, let's call this the interface used, let's give this a specific name as opposed to another interchange between components. And the one that is of most interest for us is called S6A. That's the one that is used between the MME and the HSS. And the MME in a roaming scenario is located in a foreign provider's network. That's the one taking actual care of the setup of the call. But this MME has to talk to a home provider's HSS to find out, is this a valid user? What about the charging? And so on.
Yeah. So as for the base diameter protocol used and specified in the RFC, the diameter header looks much like this. So you got a version, a length, and some flags. But very interesting and important here is the so-called application ID. The application ID determines on which interface, for once, this diameter message is used on, and also it targets a specific application on the receiving side. So you might have an application for S6A, the roaming interface, which then again supports specific commands. So you also got the field command code here, so that on a targeted application you can execute different commands, like please hand me over this phone's crypto keys, or please register this phone now as available in my network. Then you will find in the base protocol the two fields, the two identifier, the so-called hop-by-hop and end-to-end identifier, which will play an important role in the whole diameter routing scenario. So the end-to-end identifier is used to determine both endpoints of a diameter routed message, so that a message that is received on one side can find its path back to the other side, so the answer to that message. And the hop-by-hop identifier then is used also in diameter routing, but between different diameter routers. So each diameter router on the way of a message sets up like a small routing entry for that specific path the message takes, and registers the hop-by-hop and end-to-end identifier. And with this table, it can look up the path back for the answer message. This will play an important role because what this implies is that we don't need any more information. We do not need any IP addresses. We do not need any host names or so forth to receive an answer to any diameter message we will send out. So after this common diameter header, there are some AVPs, which are just fields that can be used, that can be attached to your message, and they will be used in regards to the application you target and the command you will execute. Okay, so just to show you what one of these diameter messages looks in Wireshark, this is one of the most basic ones. It's just a device watchdog request, which uses the application ID 0. This application also is specified by the RFC, and it's just to this message will be sent out frequently just to check if the other peer is still available or not. You see the both identifiers in here, as this is a handcrafted example message. They're just very nice to remember numbers. And also, you see two AVPs included here. Those two AVPs you will find in every diameter message. It's the origin host and the origin realm. So this more or less says, identifies the sender of this message. You see both of these fields have an host name like content. The format of this host name is very well defined, so it always ends with EPC evolved packet core dot mobile network code dot mobile country code dot 3gppnetworks.org. I'm sorry. The host name in the beginning, the provider can choose for its own, but yeah, most of the time they're not very complex. It will be like HSS or MME1, MME2, and so forth. Okay, also you got the origin realm, which is more or less just the last part of the origin host. So this just says this message origins from this network. Okay, so far for the basic diameter message. As we mainly focused on the S6A roaming interface, we read the specification, and it turns out there is a limited number of messages specified for this application. They're all used in the roaming context, and some of them expose some quite sensitive data. Like, for example, the authentication information request will give you all the crypto keys and authentication information for a SIM card. So we focused on mainly on this set of messages, and just to show you one example of those, I just talked about the authentication information request. This is what you see here. So it also has the common diameter header in front. You see the targeted application is S6A, and it has quite a lot of AVPs attached to it. So you see this one has different AVPs than the message before. For once, it has a session ID. Very important, so the receiving host can determine different sessions originating from your diameter host. Then it has some user data, like the username it wants to receive authentication information for. This is just an IMSI. And also there are some other values like the visited PLMN ID, which in fact signals from which network or to which network the UE wants to attach to. And then you will find again the origin host, origin realm, and a destination realm. Notice that in there is no destination host entry, because yeah, maybe me as a foreign telco network, I do not know the host name of the HSS I want to contact. I just want to know I need to attach to this network. The phone wants to attach to MCC 262 MNC 01. So how do I know which HSS to contact? I do not know. So I will just throw out a diameter message targeting a destination realm. So I just want to reach the evolved packet core of MNC 01 MCC 262 in this case. Yeah. Okay, so I do not need a host name. I just throw out a diameter message, and through diameter routing, this message will magically find its way to the right destination host. Amazing, isn't it? Okay, we will come back to this nice routing feature later. But for now, we should just take a moment and think about attacks we can derive from maybe SS7.
So when looking at diameter, especially when comparing it to SS7, given diameter is the successor of SS7 when it comes to the main signaling functions, most of the say attacks which have been possible in SS7, provided you had the right position in the network, have an equivalent in the diameter world. You might have noticed when Daniel showed the Wireshark screens, there wasn't really something on authentication. Actually, diameter can be authenticated by means of certificates, but those of you who are familiar with certificates and their operational implications might have an idea how much this is used. Actually, it's not used that much, to put it politely. So there is no built-in authentication. There is some reliance on two things, as will turn out. Some checking of the so-called host origin, and maybe, as Daniel mentioned, a certain sense of, say, hiding functions, not exposing host names or things like that. In any case, from an abstract perspective, most of the problems which have existed in SS7 before still exist to mostly the same degree in diameter. And there might be even new problems during security testing in different telco environments. We identified it's a relatively new technology, so you can identify implementation flaws, you can identify errors in the way how, say, specifications were transmitted into specific implementations. So there is even newer stuff, but let's focus on the old stuff first. In SS7, depending on the security objectives one has in mind, from a subscriber's perspective, the privacy of the subscriber's location is a quite important objective. That one, say in SS7, it was possible to track subscribers. The same is possible with diameter as well, by means of a specific message, the IDR. The R is a request, D is
data. Insert subscriber data request.
Yeah. Okay. Using this message, one can still pull or try to get hold of the actual cell ID where a specific subscriber is located. Interception, that might be actually a bit more difficult, as one has to keep in mind diameter is just used for the control plane, for the signaling. There is no actual data transport across diameter. So even if one manages to, say, to interfere with diameter, this doesn't mean one is able to interfere with the actual voice and message traffic of a specific user. To do so, one would still need, say, a local fake base station attack type to get hold of the traffic. And then, as the voice traffic is, there is encryption over the air interface, one has to get hold of the key material of this specific SIM card. identified by the IMSI, and it's the HSS holding this, which then can be accessed through diameter potentially. So two things have to be combined. This might be particularly interesting in when you recall this home IMS versus the local breakout IMS scenario. Once key material is used or is reused for the encryption of the actual RTP traffic for the voice over IP over LTE connection from. It might be very interesting for somebody who wants to get the actual content of a communication to get hold of this key material, which is where the difference comes into play. Does it terminate in the home network, or does, say, the RTP and ZIP thing happen in the remote network? From a again lawful interception perspective, the second might be much more interesting for certain countries.
Yeah. Also, if you do the local breakout scenario for voice over IP roaming, you would need to expose more diameter applications to the IPX interface. So from that perspective, you would just widen your attack surface.
From an operator's perspective, one of the main risks is billing fraud. Diameter might come into play here. We played around with this, but we weren't actually able to come up with working attacks. But let's say there is some similarities to SS7, namely when it comes to the so-called charging profiles of subscribers. Denial of service of various kinds might be possible once one is able to interfere with diameter. First, one can easily say modify the information where a UE, a specific phone is located, so that phone wouldn't get any data or calls any longer. This is focused on the phone, and once one can talk diameter to components, one can come up with sending malformed messages and all this. We did some testing here, but the specific telco environments where we were working on this were very cautious when it came to, well, you guys sending malformed packages, even in test environments, this wasn't very welcome. But there will be some functionality in the tool, which you will see in a second. The main limitation from a, say, attacker's perspective is that within diameter there is the concept of this host origin, like who is the actual originator of a specific type of message, which was within the header of the diameter messages. And components involved in these exchanges can actually check, does a specific message come from a legitimate kind of counterpart, in the sense of like an HSS, this central user authentication database, receiving a diameter message might check, oh, does this really come from an MME? As is usually over the so-called interface S6A, it's supposed to talk to MMEs in either the local or foreign networks. But so there is this kind of checking. I wouldn't really call it authentication, but say identification. A point is this value can easily be set and overridden by by an attacker. So this does, depending on the way how it's implemented, might not really help. And there is not much checking on this from our experience anyway, as the whole diameter thing, especially happening between different providers and happening through an IPX, is complex in itself. And a number of people we know don't really like to touch it. Like, well, this might break something, let's leave it as is. So there is not much checking on the host origin from our experience. In summary, before going to the more like practical part, doing the same exercise as was done for SS7, we can kind of map, say, specific message types to specific attack types, and this table gives an indication which messages might be particularly interesting when being sent to a specific entity. there was some. There was one, for example, in the DOS space. Down at in the table, there's a DSR message, which is a kind of reset, or which an HSS can send to the MME, like, oh, I'm undergoing say a reboot. Please, dear MME, cancel all active connections. So if one would be able to say spoof and inject that one, obviously it could cause significant harm, to say the least. And so now on the more practical part.
Yeah, so what we've seen is that the originating host, especially the MME host names, are kind of kept the only secret within the diameter communication. So if I know the MME's host name and UE is attached to, I can just use that host name and inject messages like I can drop that UE, I can modify some forwarding data of that UE and so forth. So the host name is a very important part in this role, and that's why a lot of people in the diameter world talk about topology and topology hiding. What's meant by this is that, as I showed before, you do not expose host names at all. So you don't have to file you had to in SS7 you had to file a page which specifies all your components with their global title. You do not have such a thing in diameter. If you want to reach a certain application, you just target the destination origin. You do not target hosts in particular. The rest is taken care of by diameter routing. Diameter routing knows, okay, you wanted to target S6A. With function X, I need to route that message over there. So that's why you do not need to expose your host names, and why a lot of people try to keep the host names, especially the MME host names, secret. And there is also a technical feature called topology hiding, which is a component right at your diameter border to the IPX, which randomizes host names, incoming and outgoing, which, by the way, I do not think is a good thing to do, because you need to keep state tables and with long host name entries, and state tables used to overflow, and just saying. So like a lot of people wanted to keep their host names secret, but there are ways to leak certain host names. I did not find one for an attached MME right now, but you can leak host names of HSS really easily. Yeah, also most of the time those host names follow a certain naming scheme. So if you can guess them, you're also good. Yeah, of course, host name spoofing, pretty easy. You can just put into the origin host whatever you like. There is no checking of this value ever. I can also, when I'm talking to you via IPX, I can spoof your internal hosts. So if you do not have any fancy diameter routing rules, the message will just reach a target. The target has no chance to determine me from the legitimate originating host and will just accept the message. And also, I will get the answer back, not the real host, because we have those fancy hop by hop and end-to-end identifiers. So that's really comfortable. Spoofing in diameter is very nice. Okay, what you could do to prevent the bad attacks here is just cross-checking values within the diameter messages. Like, there is this PLMN ID I showed you before. Maybe you also struggled while I was reading out the destination host, because the PLMN ID and the destination host name did not match. They were targeting different mobile country codes. So you could cross-check those values to make sure a message is legitimate. And also, if you keep state of your phones, so if you know a phone is attached to a certain network, and suddenly a different network asks for information about that phone already attached to your network, you can just drop the message. But that's quite complicated because you need to keep track of the state of UEs. Okay, so I did write a tool for all of this we were talking about. It's called diameter enum. It's written in Python this time, which is way more easy than dealing with the SS7 stuff. It's built around lib diameter, which I took from PyProtoSim. Kudos. It will be released under the BSD license. And yeah, it's used to send out diameter messages to an DRA, to a diameter router. So what you will need is a diameter router to send your messages to. And the best way this diameter router also has some path to IPX. And if it has, you will be able to reach any diameter node out there. So yes, this tool, as the SS7 mapper, implements probe packages for at least the attacks we have discovered. Also, I tried to implement probe messages for every defined diameter message out there. I'm not quite finished, but I'm going there. And the tool is mainly used to check your own diameter setup, to check your diameter routing setup, and if you have one diameter firewall, if there is any configuration issue, or which functionality is exposed to IPX. The tool also features a diameter application scanner, which I will show in a second. So you can, for once, determine which application is exposed on a given host name. And secondly, you can figure out if you're leaving the destination host out, you can just enumerate applications, let diameter routing do its magic, and get answering host names back. So you can map the internal topology. Okay, the tool can be downloaded here in about 30 minutes, and it will also be released on GitHub soon. Take your photos. Okay, it needs a configuration file, so I do not overflow the command line with arguments because you need to specify quite a few values, like the origin host and origin realm you want to use, the destination host and destination realm you wanted to target. Also, for the ease of use, you will specify your outgoing IP address in here. You have some values like the product name to include in the diameter messages. This could be very helpful if you want to sort out the messages out of your log files afterwards, to see, yes, that was the testing, that was not a real attack. And for the 3GPP world, you need to specify a whole bunch of messages in here, like your fake mobile network code, your fake mobile country code, the IMSI you're targeting with some messages, the PLMN ID you want to use in there, and so forth and so on. Okay, so let's go on to it. Unfortunately, I cannot show you the real stuff as I do not have a link to IPX here. So that's why I need to do my demo locally, and it will not be that astonishing. So my local setup is I have a free diameter running on my notebook. This free diameter exposes some applications and also exposes some functionality on these applications. So now I just want to check, I can show you the configuration file, which is just this. So I have there my origin host and realm, destination host and realm. I have the IP address I'm using, and so forth. Also, you can specify different values for different interfaces you're testing, but I'll not use that in the demo. Okay, so now I want to know which applications are exposed by my local diameter host. And I'm just doing an initial capability exchange. That one is printed, so you will see all the IP addresses the host is exposing. In this case, as free diameter is very talky, it also gives you the application it exposes, but this value does not need to match the real applications exposed. And afterwards, I just enumerate over all the application IDs and look if I'm using an invalid command ID. So if the application is reachable, it will answer with an error code command unsupported. But that tells me, okay, the application is available. Otherwise, I would get back an application unavailable or an routing lookup mismatch. So I'm doing the scanning once with an explicit destination host, so targeting one host, seeing what applications are exposed there. And the second time I do it without a destination host. So I'm just giving a destination realm, which means magic diameter routing is taking place, and you might get back answers from different hosts and also see different applications. Okay, so once I know which applications are exposed, I can then just start the command enumeration, which will go through every implemented command and try to deliver them. And we will see, like, okay, I have an accounting application running, so the accounting request will succeed. I now know this is a functionality exposed by the diameter host. Also, the authentication information request we have seen in the example before is not exposed, so that's a good thing. And going through all these messages, you could check if your diameter routing is correct, if your exposure to IPX has the least footprint it needs to have, and yeah, you could play some other nasty tricks like spoofing your origin host or origin realm, and yeah, let's say it like this, with a bit of config tuning, you can use the tool to perform most of the attacks we talked about. Okay. So
before we go on to that slide,
yes.
A quick comment. At this point, you might ask, or some of you might actually recall very early talks from Daniel and I when we had at this point like the slide, okay, there are so many exposed hosts in the internet. Here are some numbers. Here are some geographical distribution of those. This part is missing here for a reason. Nowadays, we consider it within ERW at least debatable, if not unethical, to do large-scale internet scanning, for the simple reason that you touch other systems, other people's systems, without usually being authorized to do so. So research projects within ERW, which include this part of scanning, have to go through the internal ethics committee, and this effort wasn't undertaken here. So I don't have numbers for you, but I'd like to let you know, a diameter it's all IP. It's port 3868. It might be implemented over HTTP, so your favorite scanning tool might not work. It's just we don't do the scanning for you. And you might come up with like, why not just ask Shodan? Well, then it's delegating the dirty, from our perspective, unethical work to somebody else, which doesn't make it better. So no numbers at this point. Feel free to derive your own conclusions. Again, it's IP. It has a well-known port, so you might be able to identify systems, and of course, you would only do so once you're authorized to do it in your own say environment and your own engagement context. That said, Interestingly enough, 4 weeks ago, the GSMA, the GSM Association, which is a kind of association of mobile network operators, they released a document called Guidelines for Independent Remote Security Testing. That's the thing I was somewhat referring to 2 minutes ago. Remote security testing, it has a section on responsibilities of testers, which I think is very important, especially given there is more research nowadays on stuff like this, and the operators are a bit concerned that this research might lead to negative impact on the availability of core systems. The thing is, this document mostly focuses on SS7, but has some diameter content in it as well. And the tool, the diameter enum, pretty much does a number of things that the GSMA guideline actually recommends operators doing. So if there are people from operators in the room, you can use diameter enum to do specifically what is recommended in this document. This document has a lot of content on different topics. I will skip this in the interest of time. And let's discuss very briefly, say what this means as, or which type of recommendations or advice we have for operators. Given, well, diameter is not exactly new, but it's somewhat, there is not like 20 years operational experience. And with diameter, there is a number of, say, dynamic factors in it. There is its own routing. There is all the, say, requirements which derive from from offering IP-based, packet-based services in a global, say, in a global setting. So the first and foremost advice from our perspective would be try to understand this world of diameter applications, which components actually offer which type of applications, which messages they need. What this might mean from a security perspective. Understandably, the security objectives of a subscriber might be different from the one from an operator. But try to understand the picture and what this means. Establish visibility in the sense of, once, as Daniel mentioned, once a UE is attached to a specific network, and there is diameter messages turning up concerning this UE from a different network, obviously this should raise suspicion. And there is a number of other things, message types which are not intended to be processed by specific applications. And actually you see this stuff. Not much of it, but once you look closely, you can see stuff like this happening in some of the operator networks we've been working on. So first and foremost, establish visibility. Monitor for known attacks, monitor for specific message types, and once you have a clear understanding, we suggest thinking about, is there anything you can do on the relationship between the origin host, where does the message come from, and what does the message actually intend to achieve or to perform? There is stuff coming in from an IPX, from one of these exchange networks. When it enters your own network, your own realm, and has an origin host in it, which doesn't belong to your network, obviously something is wrong. So this, on a very basic and high-level perspective, would be what we want to give as advice for those of you involved in operator networks. Which brings us to the conclusions. SS7 vulnerabilities, or, well, yeah, let's call them vulnerabilities. Aspects of signaling which can lead to unintended outcome. This type of things continue to exist with Diameter, as Diameter, as the successor, implements the same functions. Diameter, the more VoLTE deployments one sees, the more 4G is used, the more important Diameter becomes. So it's growing in its importance. And that's why we think it's helpful to be able to perform security research on it, which is the reason why Diameter enum was written. And is released today. Before you ask, some of you might know us, and we have a reputation, Daniel and I, of doing fuzzing of network protocols. Actually, there's a number of old talks from us on fuzzing all types of protocols. Daniel has developed an own fuzzing framework called Dizzy. So you might ask, is there already fuzzing functionality in diameter enum? Not yet, but I think there will be at some point. You might follow what's happening on Insinuator on the block, or when it comes to diameter and diameter enum. That's it from our side. Thank you for your time. And I think we have like 10 minutes for Q&A. 5. Okay, there was a question over there.
Do you need the mic?
Yeah, there is actually somebody coming.
About 3 miles away.
Hi, very cool and interesting topics. Question. First of all, that local environment you were showing before in the demo is kind of available somehow, will be available?
Yeah, it's a free diameter instance.
Cool.
Just Google free diameter and you will find it. You will struggle a bit with the setup, but it's doable.
I kind of use with telco stuff, but yeah.
For the SS7 mapper, at some point we release, gibt es nicht ein Docker-Image? Oder eine VM?
Yes, but not with a testing environment.
Yeah. But at some point, there might be like a full-blown, given with the other tool, SS7 Mapper, I would say 80% of the comments on the blog are like, oh, I have this problem setting it up, can you help me on that? There might be something. But right now, but all the stuff is available. You can implement it on your own.
Cool, thanks. Second question is a bit sort of compliant. As I noticed now, in 2017, SS7 and all the other new technologies like 4G LTE technology are still vulnerable. Now comes to me a question. GSM, if we go back on 2G, 2G is like 30 years old. 1987 was developed the first version of the spec, so it's 30 years old right now. And from 2G until LTE, we faced many vulnerabilities. One thing that came up to my mind was A52. That the stream cipher that was weakened on purpose to be delivered and installed on networks that were non-NATO countries. So that was sort of like pushed by governments, this weakened algorithm. So now my idea is, after 30 years of known vulnerabilities, how is possible that 3GPP organization or GSMA organization was unable to design proper, safe protocols? Or if they tried to design, because failing is possible, still possible, so who is the fault mainly? 3GPP organization, GSMA organization, or telco engineers? Please, telco engineers here, don't be angry at me. Or telco engineers failing on applying proper, deploying proper networks. Like, for example, you mentioned certificates. I'm pretty sure that not many mobile network operators are using, the highest defined solutions, security solutions for one type of protocol or interface. So if it's not 3GPP or telco engineers, are government states that are doing the same thing of A52, so pushing for keeping weak protocols?
I don't think it's the fault of governments, because they have lawful interception anyways.
Yeah, true.
So they already have the possibility to get in there to get all the data they need. True. I think if you want to blame anyone or anything, you should blame the complexity of the technology.
Okay. Okay.
The thing is, in theory, most of the standards, and I mean for A52, there's A53. In theory, most of the standards are, from a security perspective, reasonable, have reasonable specifications, and it could be done, but there's always like operational reality.
Yeah.
And operational reality that kicks in, and given the complexity, there's all types of trade-offs. And there has been so far for many decades the thinking of a walled garden, like it's only telcos interacting across specific interfaces, and as history has shown, this assumption might not always be valid.
Cool, thank you.
Any other questions? And thank you again, and have a great Black Hat.